Okay, cool. So reviewing this stuff, let me pop my head back in so you can see my beautiful, beautiful face. Hi. Okay, so this is what we're looking at here. We've got some problems from section 2, right? We've been factoring quadratics. Hi, Bailey. So for some of these, it's really not that bad, right? We're looking for numbers that for part A on 10 to 1. We're looking for numbers that multiply to 18 and add to -9, right? That's not so bad. You might think 9 and 2, but of course 9 and 2 don't add to -9. It's 6 and 3, right? Both have to be negative, right? We factor it, blah, blah, blah. What I want to go over is some of the ones that you guys had some questions about from yesterday's submission. So I'm going to take a look at 10 to 2, just because words are hard. And then maybe 10 to 4. Yeah. And maybe 10 to 3, 10 to 4. Some of the roots of quadratics, -3. Yeah, we'll look at 2, 2, 2, 3, and 2, 4. So I'm going to write down on a piece of paper and you'll get to see it in a second. 10, 2, 2, what's going on with that? You guys had a solution manual for this, right? And it's still up on Classroom. I would highly recommend that you use that when you get stuck. And of course, to check your answers, right? So let's take a look at what I'm looking at, which is this. Let's zoom in. All right, so here's this. And what we want to do is find the sum of the roots. So sum of roots. And I think that word in particular is confusing to a lot of you guys because I haven't been using it in class. In the product of the roots. Okay, so the things that make it equal 0, right? Whatever number you plug in here to make this equal 0, that's a root. We've been calling them zeros, right? Because they zero it out, right? But root is another name for the number that zeroes it out. So when they want the sum of the roots, let's say this factors, right? We find some factorization. It's x and x, and these are giant numbers, so I'm not going to factor it, okay? I'm just going to say, you know what? It's like s plus r. Like there's some number here, and there's some number there that makes this work. Now, you and I both know that we need one to be positive, one negative, so we multiply to get a negative, right? And they're going to add to 15, right? We could list out a bunch of numbers that multiply to this and then pick ones, right? But this is what it would look like. It'd be something here and something there. Cool, right? So if they want the sum of the roots, they want to know this. Sum of roots means this, s plus r, whatever those two numbers are, right? And the product means multiplying. So this problem actually gives you the answers for free, because if you think about it, what numbers go here? The numbers that multiply to this. So whatever s and r multiplies to, those numbers there, it has to multiply to -324, right? That's how we would pick them. The numbers that go here multiply to that. So what's the product of our roots? I don't even need to know what the roots are. I know they're going to multiply to this, right? Now, caution, these aren't our roots, right? Because if I were to plug in s to this, I get 2s, not 0, right? So my roots are actually -s. And what makes this 0? The opposite of r, right? -r. So whatever my roots are, right? They're the numbers that go in here to make this whole thing 0, right? They're going to be the opposite of whatever that is, opposite of whatever that is. Notice two negatives make a positive, right? So we're actually going to get 3, 2, 4. So the sum of our roots is 324. That's it. And of course, what do they add to? Remember, our roots are -s and -r, right? They're the numbers that you plug in here to make this 0. -s plus s would be 0. So whatever goes here, these go into the x's. If we were to add those together, we're going to get a negative number, right? So it looks like it's going to have to be -15 is what they'll add to. Because normally these two would add to 15, right? So that's all that's asking there. It's just asking you to think outside the box. Words are hard there. If you're not 100% cool with that, that's okay. We're just trying to think, what numbers do I get? Where do they go? So let's actually solve this problem. We solved it at getting what they wanted. But let me just show you how this would work. So we need numbers that are going to multiply to -324. So I need one of each, positive and negative. And they're going to add to 15. Cool. So if I list out 324, and I go down the line listing out all its factors. This one's annoying. That's why I didn't want to do it, but it'll be fine. Of course, 1 and 324, but they're not going to add to 15, even if I make one of them positive and one of them negative, right? 2, 150, and 12 makes 162. They're not going to add to 15, even if I make one of them positive, one of them negative, right? 3 will go into this, because 3 plus 2 is 5, and 5 plus 4 is 9, so 3 goes into it 100 times and 8 times, right? So 108. So we're getting closer, but still, putting those two together, you're not going to get 15. 4 will go into it. If I double that and have this, I'll get 4. So I got 50 and 80, that's 130, and then 1. 1, 3, 1. So we're getting closer. 5 won't. 6 will, though, because 2 and 3 both go into it. So if I double 3, and I have this, I get 54. If this was like -6 and positive 54, they would add not to 15, but we're getting closer, right? Be like 40 something, 48. 7, I'm not sure about that one, but let's skip it for now. 7 question mark, right? 7s are hard to figure out. Let's see if 8 will go into it. Of course it will. If 4 can be doubled and this can be halved, right? But I can double 4 and get 8, but I can't have 131, so that won't work out nicely. 9 will go into it if this is divisible by 3 again, right? If I triple this, I get 9. And if I can divide that by 3, it'll work. I can divide that by 3, right? 1 plus 0 plus 8 is 9. So how many times does 3 go into 108? Well, I know 3 times 33 is 99, right? So 33 threes is 99. Looks like I've got 3 more 3s to get to 108, right? Because I've got plus 9 to get to 108. So it looks like 3 times 36. So if I do this and divide it by 3, because I times that by 3, 108 divided by 3 is going to get me 36. 90 plus 18. Now, if I add those together, like I make that like a -9 and that a positive 36, I'm getting closer to 15, but I'm not quite there. 10 won't work because it doesn't end in a 0. 11, I think that's a no. 12, if I can times that by 3 and divide that by 3 would work, but that's not divisible by 3 because 1, 1, and 3 is 5, right? So 12 is not going to work. Man, this is a tough one to figure out. 11, would 11 go into 324? If you're not sure, you can get out your old trusty Desmos over here that I had up earlier when I was telling you guys hello. So 324 divided by 11. Ooh, close. Not quite. We know 12 won't work. Let's try 13. 13's a weird one. Nope, 13 won't. What about 14? It doesn't. I don't think 7 does either. 15, 16, 17, 18. There it is. So 18 times 18 we get a 0. So 18 squared is this number. If I double that and have that, I get 18. So there's nothing in between here and here. I'm not seeing any that add to 15 though. So this might be unfactorable, but I do know they'll add up to this. So I know whatever numbers go here are going to add to 15, and they're going to multiply to -324. Right? Okay, now let's take a look at these next ones. The ones I really wanted to look at. Where are they? Where are they? Let me show you what I'm looking at. So 10, 2, 3. This one's actually much easier. It says, let b be a constant and factor it. So I'll write that down. We want to factor this. Notice this is missing our middle term, right? We've got a squared term here, and then b is just some number, right? So it's a difference of squares. And you know, difference of squares always factor to conjugates. The reason this is called the difference of squares is because it's a difference. We're minusing, right? And they're both squared numbers. So we need x and x, positive b minus b. Done. Factored. Anything that looks like that will factor like this. Let me show you why that is. X times x is x squared, right? So that gets us our x squared. We get negative bx when I distribute here. And of course, when I distribute b here, I get the opposite of that, positive bx. So that's going to go away, right? That's nothing. That's gone. And then the last thing I get is minus b squared, right? So this is that. It'll always look like this. You will see problems like this, where you get x squared minus 49. Notice those are both squares, right? So I'll need positive 7 and negative 7. That's our factorization there. So hopefully in your notes, you're writing down conjugates, same thing, but different signs, all right? These are conjugates as well. And then this is a difference of squares. That's one of our factorizations that we should know just very easily. So that's a new thing for you guys. If you're not feeling 100% about that, that's okay, right? But make sure you're seeing this connection here, right? We get positive 7x's, negative 7x's for 0 total x's, right? That's why we don't have a middle linear term here. There's no x term, just x squared and a number. Cool. All right, let's take a look at 10.3 now. So that's just a quick review for some of the weird problems that you guys are working with. That's why they probably felt weird. So if you're feeling weird about them, that's okay. They're weird problems. What I want to look at now is this next stuff. So we've been factoring quadratics, except as it says here, we know how to factor it when the quadratic term's coefficient is 1. What about if it isn't? So what they mean by that is this. I think we feel okay about finding numbers that multiply to 1 and add the 2, right? We can factor this. Add up to this total x's and multiply to that. That's what numbers have to go here, right? And of course, 1 and 1 are the numbers we need. So we get 1x, that's 2 x's, and 1 times 1 is 1. So our answers are double roots. Both are negative 1, right? We feel okay with that. The problem is we haven't dealt with anything that has a number here, right? What if we had a 3 here? How would that change things? And that's what we're going to experiment with right now. So we're going to do a couple of these problems, and then we're going to get you guys some time to work on some exercises, ask questions. I'll make an answer key for you. I'll submit that or put that up on Classroom, right? And that's all we're doing for today. So similar to what we do in class, just without the whiteboards. So taking a look at problem number 11, I believe. No, 10, yeah. Chapter 10, problem number 11, 10, 11, right? It says, let A, B, and C be numbers such that this is true. So we've got this binomial, 3x minus 2, and you'll see it in a second when I'm done writing it down. And we got another binomial, x plus 7. So while I'm writing this down, if you want to write some notes, that's cool, right? The main thing is kind of watch the show. Hi, Bridget. Make sure you're paying attention so you can see what's going on, right? Make sure your brain's being utilized. That's why normal class we're up on the whiteboards, right? So that you're doing the thinking. Here it can work, but as long as you're doing the thinking. So notes are cool and everything. I'm going to upload this video to YouTube later so you can write notes later if you want, right? Make sure you get the big ideas down if you're going to write notes. Don't try to copy verbatim, okay? So we got this, right? 2 binomials being multiplied, and then it's going to equal ax squared plus bx plus c. So it's going to be some numbers in front of our x squared, some number in front of our x, and some number on the end there. So I've written that out. This must equal this. Okay, cool. What numbers are going to go here is essentially what they're asking, right? So for part A, what will A equal? What will B equal? And what will C equal? So I'll take care of A. We know A, this x squared, is going to come from these two, right? That's where it's going to come from because these two will multiply and make something x squared. So when we do 3x times x, we get 3x squared. So A is just the 3 in front of the x squared, right? So A is going to be 3. For bx, it's a little bit more complicated, so we'll come back to that in a second. C is not so bad, though. We know where that's going to come from, right? See how it doesn't have any x's? The only way we could get numbers without x's is when we multiply these two, right? When we distribute, right? That's going to go to everything. That's going to go to everything. When these two multiply, we'll get C. Now, here's where we do a check of the video delay. When I multiply -2 and 7, I get C, right? So what's -2 times 7? Who's got it? You can put it in chat. You can talk, whatever you want to do. I'll give you about 20 seconds. We'll see how bad the delay is. We got 2 different drinks here. We got Gatorade for hydration and Mountain Dew for caffeine. We multiply that -2 and 7. What are we going to end up getting for C? Delay is bad, children are shy.
Is it -14?
It will be -14. Look at you. Thank you. And if you guys don't respond, that's totally fine. I get it. Who wants to do that? Only nerds respond, right, Natalia? -2 times 7 is definitely -14. Cool. So what we're doing right now is we're like trying to reverse engineer this, right? We know how to distribute. That's not so bad. The next problem you'll see, we're going to do it in reverse. So we get 3x squared, right? We get -14. I told you the linear term's a little more complicated because remember, it comes from two things, right? It's going to come from 3x times 7. That's going to get us a certain amount of x's, right? So that's 21 x's. And then, of course, we'll also get x's when we multiply these guys, right? -2 and x. So -2 x's. For a total of 19, right? So b will be 19. So notice, the way we get our middle term has to do with this x times a number, right? When we distribute here. And then this other one, right? Those combined, right? They add up to our middle term, right? 21x plus a -2x. So there's A, B, and C. Cool. Part B is asking about how is A related to this stuff, right? Well, notice A came from 3 times x, right? So that 3 in front of here, which we're not used to having, right, is going to affect our A. It's also going to affect our B because it multiplies here and triples that 7 before it adds to -2, right? Normally what we were doing is we're thinking, oh yeah, these two will add to our middle, right? We'll get 5. Not the case here because the 3 is going to triple that 7 before it adds to -2, and we'll get 19, right? It's also going to affect when it multiplies with the 7, right, to make 21. So it's also going to affect our C. So having a number here is really going to screw up our thinking a little bit. So we got to be careful about it. So if I had this written out, I'd have 3x squared, right? That was our A. And I'd have positive 19x minus 14. So that's the quadratic we get, right? If I set this equal to 0 and I'm asking where will this equal 0, this is a tough question, right? Because lots of numbers could go in to try to make this 14 so that when we take away 14, we get 0, right? We know how to solve a problem like Maria. It's to factor it. Well, luckily, we have the factorization right here. That's where it came from, right? But if we wanted to factor this, what we would do is we'd think, what numbers go here, right? Normally, we put x and x to get x squared, right? But x times x gets us x squared, not 3x squared. So we're going to need this. Right? 3 times x is going to get us that 3x squared. And then to figure out what numbers here, we'd still need numbers that are going to multiply to 14, right? So -2 and 7, perhaps, right? But we also need to remember where we put our numbers matters, because whatever we put here is going to get tripled. So if we were to put our 2 here and our 7 there, we'd get 2 tripled, right? 3 times 2 would get us that 6, 3 times 2. And then we'd get 7. Of course, those aren't going to add to 19, right? So we need our 7 here, and we need our 2 here, and we need this one positive and this one positive, that one negative. So that we get 21x's minus 2x's is 19, right? So you're going to have to think, what number do I want to get tripled, right? And then add it with this one to get our middle term, right? That's what's going on here. So, of course, our answers for this would then be -7, because that will make this 0. This one's a little bit trickier, right? Normally, you guys would have a problem like this, and you're like, oh, it's 2, right? Plug in 2, you're good. Here, if we plug in 2, we get 6 minus 2, which is not 0, right? That gives us 4. So 2 isn't going to be an answer, but 2/3 would be. Hopefully by now you see why that is, and if you don't, I'm going to show you, okay? Take this right here, right? I want to know when this becomes 0, and the answer is when I plug 2/3 in here. Because 3 times 2/3, what happens? These divide out, and so I get 2 minus 2, right? So I need a number where the 3's go away, and then I get 2, so when I subtract 2, I get 0, right? So I need 2/3. Again, let me say it again. I need something where the 3 will go away. So divide by 3 to get rid of the 3. And I need a 2 so that when I subtract 2, I get 0. So 2/3 is the number I need here. If I had something like this, 5x minus 7, and I wanted to know when that becomes 0, I need a number that goes here that'll divide out the 5, right? So, and then will give me a 7 minus 7 to get 0. So 7/5. That would be our answer there. 7/5 divides out the 5, and we get 7 minus 7 is 0. Hopefully you're seeing that. If you don't see it right away, you could, of course, add 7 to both sides, and then divide by 5. Right? When will this equal 0? You can literally write that out and then add 7, divide by 5, and it'll show you. But hopefully you're seeing this quick shortcut, right? They divide out and you get 7, right? They divide out and you get 2, and 2 minus 2 is 0. So our two answers are going to be this. So not only will this affect what numbers go here and how we have to think about that, also for our answers it'll be a little bit trickier, right? We need -7 here. That one's obvious. But we also need a number that makes this 2 so that 2 minus 2 is 0. What times 3 is 2? 2/3. 3's divide out and you get 2, right? All right. Let's take this to the next level. I would also like to read a little bit. Some words of encouragement down here at the bottom. It says, according to legend, the German mathematician Ernst Edward Kummer, that's a funny name, was very poor at arithmetic and had his class help him with routine calculations. Once the class had to calculate 7 times 9 for him. One student suggested 61, another suggested 69, jokester. He said, it can't be both. And he said, it must be one or the other. Right, can't be both answers, right? So which one is it? He was not very good at arithmetic. You might relate to this man. You can be a very good mathematician. This is one of a very famous mathematician, and still not be very good at multiplying simple numbers. Because if you don't get the joke, you know, it can't be both 61 and 69, but it doesn't mean it has to be one or the other, right? Because 61 and 69 is not 7 times 9. 7 times 9 is, of course, 63. So don't feel bad if you're struggling with a little bit of multiplication. You can still be a really good mathematician. It's about thinking, right? More so than it is about memorizing facts. So now we're doing 10, 1, 2. You'll notice this is in reverse. So ABC and all that stuff are on the left side now in the factored binomials, right? On the right side, we actually know what those numbers are, right? So compare this to that, right? The right side had A, B, and C. Now we're switching it around. So we're reverse engineering this. So I'm going to write this problem down, and we're going to do the exact same thing, but with different numbers. So we get AY plus B and CY plus D. So this is the factorization of something. And they're saying it's the factorization of this thing. 2y squared minus 3y's minus 35. So apparently when you factor this, you get something that looks like that, right? We do that all the time, right? We write little brackets underneath and we try to fill out what A, B, C, and D are. So it's going to help us do that. Notice the catch is, unlike what we've been doing in our previous days, right? There's a 2 here. So that's going to be a little bit trickier, right? So the first thing it asks us to do is actually not to factor this. It says find AC and BD. Well, AC means A times C, right? So it wants us to find A times C, and it wants us to find whatever B times D is. If you notice, A times C is what gets us y squared, right? So A times C has to be 2, right? And of course, BD is this. It's what gets us negative 35. So B times D must equal negative 35. Notice they didn't ask about this part. Because remember, that's the part that's weird, right? This times this, oh, it has to be 2, right? Whatever numbers go here. Whatever numbers go here have to be multiplied to negative 35. And then this we get from like adding these up, right? And that's what they're going to ask about next. So it says for part B, we want to find AD plus BC. So part of my arrows, AD is this times this, right? That's what AD is. And then I think I'll use purple for BC. BC is this. So we're going to get ADYs, right? Some amount of y's here. And then we'll get BCYs, right? Whatever these y's are. And they should add up, right, to this. Let me show you what I mean. We'll get ADYs from this, ADYs, right? And we'll get BCYs. And of course, those would add together because they're both y's, right? Whatever those numbers are, let's say this multiplied to 15 and this multiplied to 7, right? We get 15 plus 7, we get 23, right? We know it's not going to be 23, though. Whatever this adds up to has to equal negative 3y's, right? It has to add up to this part right here. That's our total number of y's, right? We already got our y squareds. There's 2 of them, right? We already got our regular numbers, minus 35. This represents total number of regular y's, our linear term. So this has to equal negative 3y. So again, it's kind of pointing out what I was showing earlier, right? The number here and here next to our y's are going to kind of affect this middle term, right? It's going to times that one by a before we add it, and it's going to times this by b before we add it, right? So it's something to keep in mind. So now we want to figure out, using trial and error, what A, B, C, and D are, right? We know what they multiply to and all that stuff, but what are they actually going to be? So really what's happening is we're just going to factor this. We want to know when does this equal 0. And so one way to solve that is to factor. So normally we put y and y here, right? Because y times y gets y squared, but we need it to be 2y squared. So what 2 numbers multiply to 2? And we're not allowed to use fractions, thank God. What are the only 2 numbers that multiply to 2? Assuming we're talking positive, right? Let's just keep it positive. I'll wait for like 10 seconds. I don't blame if you have fallen asleep. It's 1:30, it's your nap time. Only 2 numbers that multiply to 2. This times this. 1 and 2. Thank you, Kalina. So I'm going to put the 2 here and the 1 there. Now, I don't really need to put a 1 there, right? Because 1 times y is just y. You could have them flipped. I like putting the bigger number first. You do you. It's multiplication. Doesn't matter what order. So 2y times y gets us 2y squared. Cool. Cool, cool, cool. We also need numbers that add to 35. Sorry, not add to 35. Multiply to 35, right? That's the numbers that are going to go here, right? Notice that whatever numbers go here, when they multiply, this number and this number, they have nothing to do with what goes here and here, right? So we just straight up need numbers that multiply to negative 35, just like we used to. And I can list them out. We've got 1 and 35, 1 and negative 35, right? Either of those will multiply to negative 35. We've got 5 and negative 7. And of course, negative 5 and positive 7. That's all of them, right? Because 2 doesn't go into it, 3, 4 don't go into it. 5 does, 6 doesn't, 7 does, but we already got it. So which ones do we want? Normally, we'd pick the ones that add to negative 3. You might notice none of them do, right? But here's the catch. Remember, it's going to get doubled. Whatever goes here gets doubled. And then we'll add it to whatever's here, right? So if I put like, with some guessing and checking, and you'll get better at this as time goes on. If I put like negative 1 here and positive 35 there, right? Just choosing my first choice here. I would get 2y squared. Okay, that's not surprising, right? But I would also get, and I'd get negative 35, right? Of course. But I would also get 70 y's minus 1y, and that's not it, right? If I flip them around and put like positive 35 here and negative 1 there. Now, instead of the 2 doubling the 35, it'll double the 1, but we're still going to get 35 y's minus 2. That's not negative 3, right? So I don't think that's what we want to do. Let's look at the 5s and the 7s. If I put positive 5 here and negative 7 here, what do I get? Negative 14 y's and 5 y's. If I put those together, that's not negative 3. It's negative 9, right? But I'm getting closer. if I were to flip those and do positive 7 and minus 5, I'm going to get negative 10 and 7y's. I hope you see that, right? This and this is still 2y squared. This is still negative 35 when they multiply, right? But this would double this to get negative 10y's, and this would multiply by 7 to get 7y's. So in total, what do we get? Negative 3y's, winner, winner, chicken dinner. That's what we wanted, right? We needed negative 3y's when we add them. First, this will multiply, right, and get us 10, negative 10. And then we add it to 7, we get negative 3. So this is the one we want. This is the proper factorization. So let me write that underneath here, and I'll show you one more time why that is. And then we'll be done for today. We'll give you a chance to try some stuff on your own with an answer key. And it's okay if you're feeling like 25% good about this, right? That's normal. This is the first time you're seeing this weird stuff. So don't panic, right? Just try to, especially if you're struggling to understand what's going on, try to watch more and write less notes. That's my advice. So how will this factor? We said we needed 2y and y to make 2y squared. And we said we needed numbers that multiply to negative 35, right? So we chose for this to be 7. So we get 7y's here, right? 7y's. And then what goes here gets doubled. We put negative 5, right? That gets us negative 35. Still gets us 2y squared. But now we also see it gets us negative 10y's plus 7y's is negative 3y's. So this is the correct factorization, right? There are lots of options you kind of have to search through. You might want to think a little bit about what might make sense, right? 1 and 35 multiply to 35, but trying to get those to add to negative 3 is going to be tough, right? You know, doubling 1's not going to do much. Doubling 35 is going to make it huge, right? So we need numbers that are closer together. So 7 and 5 is probably a better bet. You also might notice that since this is negative, we want the negative number to be the biggest number, right, when we add them. Negative 10 plus 7 is what we want, not this way, right? We want the negative number to be the bigger number so it comes out negative. We want negative 3, not positive 3. So probably want to make sure this minus sign is the one that's getting doubled. Then you can think about which one you want to go where, right, 7 or 5. In this case, doubling the minus 5 would be the way we want to go. So we get negative 10 plus 7, negative 3. So now that we have this factorization, which is a little bit tricky, we can see what our answers are going to be. First one's really easy, right? What's going to make this part 0? Well, when y is 5, right? Because 5 minus 5 is 0. When I plug in 5 here, I get 10 plus 7 is 17. But who cares? Because 17 times 0 is 0, right? This one's a little bit trickier. This is tricky. I want to give you guys a chance to try it, okay? I wish I could put a minus 7 here, right? So what do I times by 2 to get negative 7? Give it to me in fraction form if you can. What do I times by 2 to make this negative 7 so that when I add 7 I get 0? And again, we'll see how bad the delay is. It's got to be a fraction, right? What number do I times by 2 so that this becomes negative 7? And then we'll stop after this and go take a look at some of those exercises.
Negative 7 over 2.
Yes. And again, if you're not seeing it yet, you need to, right? So let me walk you through it so you can see it. Because once you see it, you can't unsee it. If I were to plug negative 7 halves in here, it would look like this. 2 times negative 7 halves plus 7, right? I just plug that in for y. The reason this is the right answer is because when we do 2 times this, right? See how it says divide by 2? The 2's will divide out, and we'll get negative 7 plus 7, which is 0. So think I need to divide out the 2. That's got to go, right? So I'm going to divide by 2. That's where this comes in. And then I need negative 7. So when I add 7, I get 0. So negative 7 halves. Or negative 3.5, right? Negative 3.5 times 2 is negative 7, and you win. Now, the reason you might want to do negative 3.5 over negative 7 halves, right? Why you might prefer that is because it's timesing by 2, right? You're pretty good. A lot of us are pretty good about thinking what number times 2 gets us 7, right? But if it was like, I don't know, a 5 there, you wouldn't want to think about what number times 5 gets me 7, right? As a decimal. So like if I had this, it'd be harder to answer, right? Yeah, negative 3.5 times 2. That's not too bad. But what times 5 gets you negative 7? Tough. But if you think in fractions, it's really easy. If I times that by 5, I get negative 7, right? Start thinking with fractions, especially improper fractions. It'll make your math a lot easier. So here are 2 roots, our 2 zeros, right? 5 gets us 0 here, so it's a root. And negative 7 halves is a root. Not to be confused with this type of root, square roots, right? Different thing. So this root gets us 0 here because when we times it by 2, we get negative 7 plus 7. So I feel like this part is a little tricky because now we have fractional answers, right? So that's a little weird. I might want to get that in my notes. How do you solve a problem like Maria, right? The other thing you might want to do is get down some notes about how this affects all this stuff. And there's a lot of mumbo jumbo here, right? So looking at this, easy, 2y times y is 2y squared, right? I need numbers that multiply to 35. There's some options, but they also have to add to negative 3 after this one gets doubled. Right? Let's go take a look at some exercises. I'll give you an answer key. If you have questions about stuff, you can ask questions now. And then we'll let you out. So let me show you what I'm looking at. I'm in the book in 10.3. If I skip past all these extra problems we haven't done yet, because we'll do those in class, and I go to the end of the section, I get way down here. There we go. On page 307, just before the next section, right? Some exercises. So it's asking you to find all solutions to all this stuff. So I'll just show the first one real quick, and then I'll post an answer key for all of these on Google Classroom. So it looks like we got 10x squared, and I'll show you it in a second, minus 11x plus 1 equals 0. There we go. So what numbers multiply to 10? We have options, right? 10 and 1 and 5 and 2. So let's try 10 and 1 first for here. I need numbers that multiply to 1. And they have to add to a negative, right? So I'm going to do negative 1 and negative 1 because they multiply to positive 1. And if you look, this is the correct factorization. I'll get 10x squared. I'll get positive 1, right? That's what I have there. And then I'll get negative 10x's and minus 1x. And if I simplify this, that's negative 11x's. So this is the same as that. So when will my answer equal 0? When x equals 1. And then how do I make this 1? What times 10 is 1? 1/10. 10's divide out, I get 1. Okay? So I'll give you answer keys for this. I'll start writing them right now. If you want to leave, that's fine. If you want to ask questions, that's cool too. Once I'm done writing out the answer key, I'll upload it to Classroom just like I would put on the board normally. And I will see you guys, I think, tomorrow. We'll see. We'll see. Again, if you have any questions, ask them now. But otherwise, I'll just write down this answer key.